Now, Dad mentioned your test is on Wednesday. Is that your final exam or is that the first part of it?
Yeah, it's the first part of the finals. So he split it up into two finals. So there's one with a calculator on Wednesday and then one
Okay.
without a calculator on Friday.
That's really good to know. Okay. Yeah, so I do see what you sent over here. You want us to work on any of these, some of these?
I think if I can just do one, I think I'll kind of get the gist of it. I think
Got it.
21, since I already did part of it.
Okay.
I
Yeah,
think I'm trying to find R. And then also, can we do 18 as well?
sure. Let's just start with 18 at the top there. The picture
Okay.
looks a little compressed, so I might have to ask you for some numbers here.
Oh, I'm
That 20,
sorry about that. I didn't know it's not
yeah,
like that.
yeah, sometimes they compress and they say no big deal. You invest $2,400 in a certificate of deposit that compounds interest monthly at a rate of, is that 3.25%?
2.25%.
2.25. So this is P, this is R, 2.25%. We will take the 2,400 to grow to 3,200. So that's the future value. You're trying to get to 3,200 and it's done monthly. That's N equals 12. So there's two types of problems that you're going to see here. One is continuous compounding, which is garbage. No problem in money is ever compounded continuously, but they put them in these textbooks. And then the
Yeah.
non-continuous. Yeah, seriously. I mean, it's ridiculous. You
Yeah.
will never see an institution compound money continuously. So the non-continuous is what you're dealing with here. So the formula for that is the future amount is the initial amount, 1 plus the interest rate divided by the number of compounding periods to the number of compounding periods times t. I know that's a lot to take in, but they always give you everything but one. You don't have to worry about a situation where you're not going to have uh, everything but one.
Okay.
So for the interest rate, you do have to convert that to a decimal. You're dividing by 100 to do that, 0.0225. You do have to know that monthly means N equals 12. There's weekly, monthly, annually, quarterly, daily. There's a lot of options there. So just be kind of familiar with that, or I can give you the full rundown of that. So
I
you
have
need to
it
put
I have it written down on the worksheet somewhere.
fantastic, fantastic. So 3,200 equal 2,400, 1 plus 0.0225 over n, which is 12, to the 12 times t power. Is that
Cool.
okay from what I've done so far?
Yeah, that's perfect.
So our goal is to solve for t. And this is where the challenge begins. First thing is to get rid of this 2,400 on both sides. You can go to your calculator. You don't need to yet. You can just leave it as 32 over 24 or 3,200 over 2,400. It doesn't really matter. You can even divide it up, further and get 4 over 3. Okay, totally up to you. You can also combine what's inside the parentheses, but you really don't need to. I am going to do one other thing though here. There's this um, we have to remind ourselves that how do you get a variable out of, or how do you get the variable out of the exponent? Do you remember that from earlier in the course?
Yeah, it's you take the inverse.
ln. Like
ln.
if
Okay.
it were squared, you'd square root it, but you use ln to get a variable out of the exponent. So you take the natural log of both sides. Now, the natural log allows you, sorry, I put that in the wrong place. It allows you to bring the exponent out in front. So this 12t actually comes out in front. Does that look familiar to you or not?
No.
Okay, that's not good. Should we do a different problem to kind of lead into this, or?
No, I think we can keep going.
Okay, so 12t natural log 1 plus 0.0225 over 12, like that equals natural log of 4/3. We're solving for t. Like we got to get t by itself. There's this 12, which we're gonna get rid of by dividing. You're gonna divide both sides by everything but the t. And that also goes on the left, which I've not left enough room for, but let me reframe this a little better here. It's kind of messy. Okay.
Oh,
But
that's
everything
fine.
does cancel. Everything does cancel on the right. You are going to your calculator. So now it's just a matter of putting it in the calculator correctly. Now you're using like a TI 8384.
Yeah, I have a 84. I just use it for the SAT, so I don't know where I put it.
Okay. Yeah, no problem there. For now, let me send you a link to a calculator I suggest students use. I don't have any affiliation with them. The Desmos Scientific's pretty good. You can enter it the way you see. You don't have to make any sort of modifications. So let me show you that here. I'm gonna just enter it in. All right. So I definitely will need a calculator for future lessons, but just because I want to get the maximum out of this. When you put this in the calculator, you end up getting your answer here for T. So about 12.8 years.
Okay, hold on. I have a scientific calculator too. I don't know. That's right here.
So if you're going to use your scientific calculator, you will need to be careful adding some parentheses to the bottom. You'll need an extra set right there. Otherwise, it'll potentially do the wrong order of operation.
Okay. I know I have. All right.
There's several other problems here that are going to require the calculus. It's up to you if you want to try the calculation. I usually like you to, but first lesson,
I have the app on my phone for the TI-84, so I'll be
okay.
fine.
Great. Okay. Any questions on that? Any follow up before we move to 21?
I don't think so. That looks great.
So the ones where you solve for the interest rate, which I think is what you're asking for in 21, is perhaps the most difficult. Let's just take a look here. So $1,000 is invested for 4 years. So you'll notice like I try to write the values as we go. $1,000 for 4 years, T equals 4. And the interest is compounded semi-annually. That means N is 2. If this amount grows to, that's the future amount, 1435.77. And then they want the value of R. Do you think you'll be given this equation or will you have to memorize it?
I'll have to memorize it. I have it memorized, I think.
Okay, fantastic. Like I said, they always give you everything but one. So this time the only thing they're not giving you is R. So you just put the numbers in and you work it out. It's a lot of algebra, but by now you should be capable of doing something like this. 2
Oh yeah.
times 4. So it's just a nuisance. It's like you know what to do. You just got to get there and do it. No shortcuts here. So divide by 1,000. Looks like you had that started on your paper there.
Yeah.
And then 1 plus R over 2 to the power of 8. And this might have been what you're referring to in the previous problem. To undo 8, you do use the inverse of a power of 8. Do you remember what that would be?
Log base 8.
Okay, that does
Or-
work. That is well, that's unnecessary. Let me remind you, how do you undo a square?
Square root.
Square root, and you undo a cube with a cube root. And this is really,
Oh, okay.
it's
So you
really to the
take the
power of 1/2. So you're going to take the 1/8 root of both sides.
okay.
So it's really bad now on the left. Like this doesn't mean anything, but you got to write it. On the right, the you just have the 1 plus r over 2. I'm going to switch sides here. 1 plus r over 2 equals 1435.77 over 1,000. It is best to wait until the end. If you want to do the intermediate calculations, go out more decimal places than you think you need. So we're still trying to solve for r. Subtract 1 from both sides. So you get the same thing. The 1/8 power, but you subtract 1, and then you multiply both sides by 2. And it's all this stuff. It's probably the hardest part is to just get it in the calculator without making a mistake here.
Yeah.
The other thing to think about is like, what's a reasonable answer for this? Interest rates aren't big numbers. There should be like, we'll just say like between I don't know, 0% and 20%. Like you shouldn't get a huge number when you do this. That's kind of your reasonableness check. Is it right or not?
Okay.
I would encourage you to give this calculation a try. I'm going to enter it into the calculator here. And your instructor chose nice numbers because this does work out nicely.
Sorry, I'm just a little bit behind here.
Yeah, I apologize. If you need me to scroll up, say, hey, Matthew, you're going too fast, or you want to get caught up. This time is for you. Don't let me rush you or push you to.
Oh no,
fast.
this is fine. 4, 3, 5, 7, 7. So is it about 9.25%?
Exactly. Yes.
Perfect.
Really good. All right. Where do you want to go from here?
I'll send you over some law of sines and cosine.
Okay. Yeah, those are good. For future
there-
lessons. Go ahead.
Is there a way I can send it to you or it doesn't compress like that?
When you email, most of the time it asks you if you want to send as the original size or compress, and depending on what you're using, sometimes you've already set the default to compress it.
Okay.
I'm not sure to answer your question, frankly.
No, you're
but it's standard question when you're sending an email. It's like, do you want to compress?
I think I know what you're talking about. Oh yeah. Okay. Okay, it should be a lot better now.
All right. And I was going to say is for future lessons, you're welcome to send over as much as you want before the lesson, during the lesson. This is all business stuff. It's not going to interrupt me.
Oh, okay. Perfect.
So,
Sorry, I didn't know what to send over.
yeah, that's okay. That's why the first lesson we're always kind of figuring it out. Like, what are we going to do?
Yeah,
All
that's
right.
okay.
So it looks like you've worked through some of these. Do you want us to work on the ones that you've not
I
done?
this was from a long time ago, like a couple months ago. So we could probably redo them and be
Okay.
fine.
So
Or we could
let
just do
me,
number 4.
yeah, we'll start there. I want to tell you why or when you use law of sines versus when you use law of cosines. That's a big It's important to know the difference. So with law of sines, you're looking for an angle side pair. Okay, and we'll use 4 as an example of that. I'm going to snip that in here. So what I mean by an angle side pair is you have the angle and the side across from that angle like that. Could be any of the 3, but you got to have at least one of them.
Okay.
Okay. In both cases, you can use law of sines or law of cosines to solve for a side or an angle. So there's no way to like differentiate between that. For law of cosines, there's 2 cases that you're typically looking for. You're giving all 3 sides or side angle side. When you're given all 3 sides, you find the angle. When you're given side angle side, you're solving for a side. All right. So that's kind of the overview. It's the Cliff Notes version. So let's look at this problem here in a little more detail. Again, I'm going to send this over at the end. So if you don't get it all down, don't worry about it.
Okay.
My preference, and okay, let me actually write out what law of sines is. So it's sine A over A, sine B over B, sine C over C. But the thing is, you only ever use like the first 2, second 2, or the first and the third. And you can sometimes you use it in such a way where it's flipped, depending on the problem.
Oh, okay.
So like some students like to have all the formulas down. I'm not that type. I think it's better to kind of understand them, but you do what you want. You get a final coming up. Don't let me influence you quite yet
Okay.
on that front. But more importantly is like I always put the thing you're trying to find in the top left. That's just my standard go-to. And so the thing we're trying to find is measure of angle A. And so you can put, okay, little a below it. And then you have to use the given stuff. So you're given sine of B, or you're given angle B and side B. And just like the previous problems, you have to be given 3 of the 4. If you're not given 3 of the 4, you've either done it wrong or you missed something. That's what is required. So we
Okay.
don't know big A, but we know little a of 7, sine of 75 over 28, like this. Is that okay so far?
Yeah, that makes sense.
All right, I'm gonna bring that down here. Any idea how to solve something like this?
Would you just use like the cross multiplication, like the sine, like the 28 sine A is equal to 7 sine 25?
Yes, and that does work. There are other ways, but that is fine for now. We'll say that's good. Your goal is to get to the sine A or the A, so you have to divide by 28. And so it becomes sine A equals 7 over 28 sine 75. But you're not done. You're solving for A, not sine A. Solve for A, which means you have to undo sine. You remember how to undo any of the trig functions, sine, cosine, tangent?
Um,
Sine
uh,
inverse.
oh yeah.
You undo sine with sine inverse, cosine with cosine inverse, tan with tan inverse, and so on. So, so there is a step where you take the sine inverse of both sides, but really it's just the outermost function here of this. So what some students do is they get the 7 over 28 sine 75 in their calculator. They get the answer and then they take the sine inverse of that. Make sure your mode, very important now, is in degrees, especially if you're moving back and forth, maybe depending on what classes you're taking.
So you'd take the sine inverse of, oh point, wait, sorry, let me put this back in full screen. Sine inverse of, okay.
Like I mentioned, some students, they go and they feel I'm gonna get 0.24, 1.4, 8.4. They do that, or you can do it all at once.
So is it about 13.97 degrees?
Yeah, maybe 14. Yep, good. So
Okay,
you just need the measure of angle A. Now, I'm just
that's
gonna
a lot
add
less
this little,
overwhelming than I thought.
yeah, so sometimes they have you do more. To find angle C, you need to use law of sines. The sum of the three angles in the triangle add up to 180. Okay, so you just subtract from 180 if you're asked to find the other stuff. If you're asked to find little c, you do unfortunately have to use law of sines.
Okay,
But yeah, it's not that bad. You have to know the formula. You have to be comfortable solving for an angle or a side. Now, there is the ambiguous case where you have two possible triangles, but I don't believe you have that here because of the way they've drawn it. And it's probably not something you'd have in a final, but you might ask about the ambiguous case, which is basically when there's zero triangles or two triangles. This is just one of those, like, is it going to be on the final? If you think you'll get an answer.
yeah, I haven't heard that, so I don't think it will be on the final.
Okay. Very good. Okay, so you got more on this page. We should do a law of sines problem. Unfortunately, none of the rest on this side are law of cosines. None of these are law of cosines on the rest of this page.
Some of them on the, hold on, let me send the back side. I think
Sure.
it says law of sines and cosines, so.
Yeah, I'm sure they're building up to it.
So if it's side angle side, then it's law of cosines.
Yes, and the angle has to be between the sides. It's not just any arbitrary angle. It's got to be
Okay.
between the two. It's got to be a V, basically.
Yeah, then
Side, angle, side.
the back looks like it's law of cosines then. Let me send you a
Okay,
picture.
sounds good.
Did it send okay?
I just saw it here.
Okay,
Uh,
perfect.
Got it. Yeah, thanks. All right. Do you want to do one of each or just one? The harder one, like 10 is the hard. That's the harder one is 10, or sorry, 14. Harder one is when you find the angle. The easier one is when you find the side, like 10. But if you want to do both,
Let's do one of each, I guess.
okay. All right, let's do 10.
All right.
All right, so you got a side, you got an angle, you got a side. The only thing you can solve for is the side across from the angle. So the law of cosines comes in three forms. C squared equals A squared plus B squared. So notice this is the Pythagorean theorem.
Mm-hmm.
Minus 2AB cosine big C.
Whoa, hold on. Okay. C squared
Yeah, this formula works for this problem, but I guess I wanna like either show you or tell you the other formulas. But I want you to see how they, how you can actually you only need one formula to get them all. So in the first formula, notice that A and B are the same as the A and B here that are being squared. The angle C is the same as this C over here. So when you solve for B squared, it's the other two letters. You use the same other two letters, and then the B matches with the big B.
Oh, okay.
So
That
you're
makes
not
sense.
actually memorizing three different formulas, although it can seem like that. BC, and this is how I remember it. Like I don't remember that stuff. I just know how to get from one to the other because it's just
BC
too
and then
much.
cosine A.
Exactly. Okay. And more generally, you can use words like um, the side across from the angle is what's going here. These are the other two sides, and then the angle between. So this is the better way to remember it. Now, there's even three more formulas where they solve for the angle. We'll look at that next, but I recommend just memorizing one of them and then doing your best to do it from there. You have some choices here. You can start putting the numbers in, which is probably a good idea here. So let's go with that. C squared equals, it doesn't matter the order, 19 squared plus 27 squared minus 2 times 19 times 27, cosine of 80. So you want to be able to get all this into your calculator. You do have to remember to take a square root and think about your answer reasonably, like 27 to 19. Like, I don't know what this is, but
It's not going
it's
to be
not,
like huge.
yeah, it's gonna be like 50. It's not gonna be 2,500, you know,
Right.
so don't, square root's important here. So you want to go ahead and calculate that for us, please?
All right. 19. So let me do this on this calculator instead. I got a huge number.
It ends up being about 911. I don't know if that
Yeah.
was, that's okay. You just gotta take the square root of that.
Oh, okay. I forgot about that part.
Yes.
What was it again? I erased it.
It's 911.836, yeah, 967. Get
Oh, that's fine. 9, 8, 3. So about 30.2.
good. Okay. And what I'm about to say, really important here. Let's say you were asked to find other stuff in the triangle. Because you already have an angled side pair now, you do not use law of cosines ever again. You go to law of sines. It's much easier. You only use law of cosines one time
Okay.
because you now have an angle side pair. That only matters if you're trying to find other stuff. Like if you need to find angle B, use law of sines now.
Okay, that makes sense.
All right, so let's look at 14. So this is the other possibility. The other possibility is you're given all three sides and you have to find an angle. And like I was mentioning, like you you can um you can start from this to find it. But what some students do is they memorize the formula for cosine C or big C. I would recommend just memorizing this and but what do you think? Like, do you want to know another formula? Like, do you want to know that it's what is it, a squared plus b squared minus c squared over 2ab cosine inverse? Do you think you'll remember this?
Oh, no, I'll
there's-
just use the first one is totally fine.
Okay, good. And that's why I would recommend. So you do, it's good to kind of label the things, especially if they're not that way you don't accidentally mix something up. So this is 14 squared equals 9 squared plus 6 squared minus 2 times 9 times 6. So it's sine big C. If you can wait till the end to do the calculation, it's usually a little better. Up to you if you want to multiply this out, or you can just divide it by it and do the calculation at the end. So we'll just switch sides here. So cosine C equals all of that. And then you can get this number on the right. If you are using a scientific calculator, add parentheses in the numerator and denominator. That way order of operations holds the way you want. And then you do have to take the inverse cosine of both sides. So like even when you get all this, you still have to undo it with
The inverse cosine.
yeah.
Okay.
And
Wait, can you slow down for just a second? I need to write all this
sure.
stuff.
Sure.
Oh, okay, so I see. Cosine C. Okay. Cool. That makes sense.
Yeah, so just be careful putting this in the calculator. There are some scenarios where you get an undefined answer, and that more likely than not means you made an error when you put the calculations in or the numbers in. So always good to do the calculations twice just to confirm, like, oh, it's me that made the mistake. It's not that it's an undefined problem.
Right.
Um,
Hold on, I got a weird number.
So the first one is minus 0.73148. When you do all this in the calculator, is that what you got or something different?
I got negative 2,133.
Okay, so again, make sure those parentheses are in the numerator, denominator, to add to make sure you're doing an order of operations. Like you're doing all this stuff first, then all this, then you're dividing.
I did. That's weird. Hold on. Maybe I screwed something up in the denominator.
It's likely just a parentheses imbalance.
Minus 9 squared. Okay, there we go. I got the
All right. And then you gotta take the cosine inverse, and that gives you about 137 degrees. ish.
42.98 or
Yep.
43.
Make sure your mode is in degrees. And then negative. I don't know if you got the negative in there. Should be 137 degrees.
Let me look. Oh, I forgot to put the negative. Cosine.
So once you get that angle, if you were asked to find something else, you would use law of sines. You would not go back to law of cosines. You only use it one time,
Okay.
unless they demanded that you use it. Sometimes see that, but all right. So just to be clear, so my lessons are 50 minutes. So we got about 10 more minutes. So if you got something else urgent, you might want to do that next.
Okay, so let's do one more thing. But I think I'm good on sequences. Um, and then we have a lesson tomorrow too, right? I think.
We've not scheduled anything, but I can get some stuff scheduled with that.
Okay.
Um, might be late again.
That's fine. I think optimization will be easy for 8 minutes.
Okay,
I'll send it over.
sounds good. Yeah, I forgot you to mention that. It'll either be 8 or 10 tomorrow. So
Yeah, either of those work, whichever
okay.
one's better.
All right, there it is. Okay, is there one that you would recommend, or one that you want us to do more than another?
Let's
They look
do
looks all
no.
somewhat the same.
Yeah, I think these are all the same. Let's just do number 3.
Okay. All right, here we go. Let's nip this in. All right, find the cheapest possible cost to run a power cable from a power station on the coast S to a marine biology station on an island there E. So okay, so what's the standard cost? The cable across land is 1150 per linear foot. Cost of the cable underwater is 2150 per foot. The coast is straight and the optimal cost. Okay, blah blah blah. All right. So the path here is you go along land at some point, and then you switch to the water like that.
Okay.
And the idea is that they usually don't give you, they usually don't tell you, break the way that they usually just tell you, oh, this is like 10,000 feet. And you have to figure out, well, is it X there or X there? It doesn't really matter, but they're doing it for you. They're saying like, call this X, and then this is 3,000. So you need the hypotenuse as well. You need we'll call it C for the moment. So to find C is Pythagorean theorem. C squared equals X squared plus 3,000 squared. Is that okay? Clear?
Um. Oh
Like
yeah, Pythagorean theorem. Yeah.
yeah, it's a right triangle. So C is the square root of X squared plus 3,000 squared. You can square it if you want. So the cost function here, the cost function is the cost is equal to the cost to run it on land. So the price on land times the length of the land plus the price on the water times the water length, we'll say. And we're going to actually substitute numbers in, but it's the price to go on the red, price to go on the blue. Is that kind of okay conceptually?
Yeah.
So they're telling you it's 10,000 minus X. And the price to run it on land is 11.5. The water is more expensive. And that's the square root of this here. All right, so I do have a virtual TI-84 I can grab. You said you do not have a TI-84 or you've got one on your phone or something?
I have one, but I just use it for the SAT and I can't find it. I have one on my phone now that I can use.
Okay. Do you want me to show you to do on the calculator or just graph it using Desmos or something else?
Graphing it wherever is fine.
Okay.
I know how to do it on the calculator.
Okay, fantastic. So the main thing with this one is entering it incorrectly, which you said you're fine with, and then getting the right window, which is huge hassle, but
That is
I'm
annoying.
going, I'm so I'm just graphing it here. I'm going to snip it in once I have something to show you. All right. I guess it's pretty large. Sorry, I'm trying to get the number. Is that 10,000? Did I did that? 10,000. Right. Let me get the window to scale just a tiny bit better. Let's go. Give me just 30 seconds. Be right back.
Oh, you're good.
All right. I do have the graph here. Sorry, it took an extra moment to get it to
That's
kind of
fine.
sync up here. But the graphing is the most annoying part of this because you got to hit your window right, and you get two coordinates here. You're looking for the min. You probably have that second calc min. You get your left point, you get your right point, your guess on your calculator. And there it is. So it's about 1899. X is about 1899. So this is the cost right here. So when you take calculus, which it sounds like you might, you'll learn how to do this by hand. Although this one's pretty rigorous. So you may not want to do that. But
Yeah, I'm taking AB next year.
fantastic.
So do you have any tips for like finding the window?
Yes.
I think that's like the hardest part for me.
The 10,000 to X is the indicator here of your X. So that's how I kind of got this dialed in down here.
Okay.
Is that the Y?
So I should put in like 10,000.
Yeah, but so there's kind of a trick here to go zoom fit. And it doesn't work great, but it kind of gives you like a little bit of help.
Wait, what was it?
Zoom fit. It's like zoom 9, I think, with the IA3. But the other option is you always increment your scales by powers of 10 or 2. Basically, you go up by 10 times 10 or times 2, and you just keep guessing until you get it.
Okay.
That's truthfully all I'm doing. I'm not doing anything that special there. All right, we do unfortunately have to stop